In this video, we're going to focus on dividing functions using function notation. So this is the first time that you're seeing dividing. The first three, adding, subtracting, and multiplying, they are things that you focused on in Algebra 1. We did not spend a whole lot of time focusing on division in Algebra 1, so this is going to be fairly new to you, so just make sure you're paying careful attention here. So here's the idea of dividing functions. We're going to say, set it up in a fraction. That's what dividing really is. So let's start off with that. This says f divided by g, so I'm going to come over here and I'm going to say the f function should be on top. That's x squared minus 9. Okay, and the g function should be on the bottom. That's the x plus 3. Right. So what I'm telling you up top here is that in order to work with these, you need to factor the numerator, factor the denominator, and cancel any factors that match each other. So I want to show you a simpler example that to kind of let you know that you've been doing this for years, you just didn't know it. So here's a fraction, right? This is a fraction, so I'm just going to write a simpler looking fraction, like for example 3 over 9. That's a fraction too. Okay, if I were to factor the numerator, what I mean is break this up into things that multiply to 3. Well, I'm going to do it just like that. Okay, break the bottom up into things that multiply and give me a 9. Well, that's 3 times 3. Okay, and then I'm going to look for any matching factors. Well, I see a 3 on top that can cancel out with the 3 on the bottom, and my result is 1/3. I only have a 1 left on top and a 3 on the bottom. So 3/9 is really the same as 1/3. Okay, you've been doing this for years. We call it simplifying fractions, right? So we're doing the same thing here. We're going to say, I need to break up x squared minus 9 into two or more things that multiply and give me an x squared minus 9. That's called factoring. So we're going to factor, and it's going to be x plus 3 and x minus 3. Okay? And the bottom x plus 3 doesn't factor into anything. That would be like a prime number. Like if I had a 7 here, you couldn't really factor that into anything. Right? So I'm going to say in this case, x plus 3 on the top, the entire expression x plus 3 will cancel out the entire x plus 3 expression on the bottom. You cannot cancel out just the x's or just the 3's. I need entire matching expressions, and in this case, an entire x plus 3 and an entire x plus 3. So my final answer here is just the x minus 3 on the top. I don't have a denominator anymore, so I'm just going to leave that out of the problem entirely. That's kind of like being over 1, right? I don't need to write that. So my final answer to their problem, what is f over g of x? Well, the answer is that it is this expression, x minus 3. Okay? That's the division part of it. Set it up in a fraction, factor the expressions, cancel out anything that will cancel. Okay? The other part of this is that we need to declare the domain for this function. Okay, f over g of x. So if you remember in the last videos, we talked about how the new function, our answer, our quotient, is going to inherit the domain of the original function. So I'm going to have to look at f of x and look at g of x and determine what their domains are. So in this case, this is a quadratic function. The domain of every quadratic is all real numbers. So I don't have any restrictions on what I'm allowed to square. And this is a linear function, which also happens to have all real numbers. So far, we're going to say x minus 3, my resulting function, is going to inherit that all real numbers. Okay. So here's the other part about division that's a little bit tricky. So part 1 about domain of quotients is what we just talked about. If either of the original functions has a restriction, then our new one is going to have that same restriction. In our case, in our problem, they were both all real numbers, so I didn't have anything going on there. So we still need to look at that. Okay? But we have a second thing that we have to worry about now. You are not allowed to have 0 in the bottom of a fraction. And when I'm dividing, I'm setting up a fraction, which means this expression, my denominator, okay, cannot be 0. Right? So we're going to say in this case, this expression cannot be 0. So I'm going to come down here right below the problem and say, all right, let's take a look and find out when that's 0 so we can tell people not to do that. Right? So I'm going to just right here say, okay, when, okay, I'm really asking the question, when is x plus 3 equal to 0? Okay? And we have to solve this problem. Well, x plus 3 is equal to 0 if I solve it when x is equal to negative 3. Okay? When is x plus 3 equal to 0? When is the denominator equal to 0? Well, that's only at this point right here. So I'm going to tell people that the final answer is x minus 3. That's the quotient. Okay? But let me also tell you that x is not allowed to be equal to negative 3. Right? So I'm saying the answer is this, but by the way, don't use a negative 3 because that's not a part of the list of x values that you're allowed to use. Okay, so even though the answer right here, it's okay to plug in a -3, there was a spot in our original problem where it's not okay. If I plug a -3 in right here, I get a 0 in the bottom of the fraction. That is not allowed, right? So anywhere along your entire problem, if you find that 0 makes the denominator, that a number makes the denominator 0, make sure you include that in your restrictions at the end. Okay, so let's take a look at another problem that's a little bit more work. Okay, so we're just going to focus on the domain and the range part of this. Oh, well, we'll do both parts of this. Okay, so I'm going to start off by setting this up. This is f of x and g of x. This says let's do f of x on top, 2x squared minus 3x minus 2, and g of x goes on the bottom. That's 2x squared plus 9x plus 4. Okay, so let me caution you first, because I know that there are some people that want to do this. Okay, you see the 2x squared on the top and the 2x squared on the bottom, and you want to cancel them out. Okay, here's the reminder: you are only allowed to cancel out entire expressions. So 2x squared is a small term of a big expression. The entire thing's got to go, or you can't cancel it out at all. So I have to actually take this and say, what does this factor into? Well, this will be AC factoring. It's going to turn into two of these. I'll let you work on that on your own. In this case, I'm going to just kind of shorthand this one and say, using guess and check, I can probably say, okay, I need probably a minus sign here and a plus sign there. So let's just double check. This is -4x, and that's +1. That does work for the middle. You can use AC factoring and go through the process of factoring this yourself. I'm going to let you do that on your own. Okay, the bottom factors as well. Okay, and I'm going to factor this one into 2x plus 1 and x plus 4. And again, I'll let you go through and prove that that does factor like that. What I care about is when it's in its factored form, when these two expressions are factored, that they both have a whole factor of 2x plus 1. These are going to go. My final answer here is x minus 2 on top, x plus 4 on the bottom. Okay, I am not going to cancel out x's. I am not going to say that this is a half. Okay, the entire expression has to go away. I'd need another x minus 2 floating down here to cancel out this one, or the entire expression's got to stay. So my final answer to the division part of this problem is this expression right here. Okay, I canceled out 2x plus 1s. The other part, it says identify domain restrictions. So again, my original functions, if I take a look, quadratics, all real numbers. So I have no domain restrictions coming out of the function, the original function part of this. Okay. However, what I need to do is say, let's take a look at when any of these factors in the denominator, when are they going to become 0? So if I'm going to set each of these equal to 0, when is 2x plus 1 equal 0? Well, that's when x is equal to -1 over 2. Okay. When is x plus 4 equal to 0? Okay. That's when x is equal to -4. Okay. I don't care about the numerator, so this x minus 2 is fine. I don't have to include that. Just when the pieces in the denominator become 0. And these are my two values, -1/2 and -4. So again, I'm going to say my final answer is, okay, x minus 2 over x plus 4. Okay. And here's your restrictions. X cannot be equal to -1/2 or -4. Okay, so I'm letting people know that my answer is okay, but all throughout this problem, make sure that you don't use either of these values. Even the one that we canceled out. We canceled out 2x plus 1, but it still needs to be represented in my domain restriction. Okay, so that's the idea of dividing. We have to make sure we divide, cancel factors, find a domain restriction. Okay,